Okay, I'm going to show you how to name structures or how to draw structures. These are homework problems from chapter 12. So this is a section on alkanes. So we're going to name these things. But first, I'm going to show you this cheat sheet that I put together. And for this chapter, we're dealing with alkanes. This is the basic structure. Everything is a single bond. The ending is ane. Here's an example of ethane, and here's the name, ethane. So, these are relatively simple examples, but I'm still going to insist that when you come up with the names of these structures, you start by naming it from the back and work forward. So for example, this is an alkane, so the ending is going to be ane. And then the prefix is going to be 1, 2, 3, 4, 5, pen. Pentane. So the name of this compound is pentane. So let's do B. Again, these are alkanes, so working from the back, they're going to end in ane. 2 carbons, that's eth. So this is ethane, ethane. The next one, C, is a line angle drawing of 1, 2, 3, 4, 5, 6. 6. Again, it's going to end in ane. 6 carbons, so the prefix is hex. So this is hexane. Let's do D. Again, it's going to end in ane. It has 1, 2, 3, 4, 5, 6, 7. So that is heptane, but it's cyclized. So this is going to be cycloheptane. Cycloheptane. Okay, for this problem, we're given the name and we're asked to draw the structure. So, methane, that's as simple as you can get, but generally speaking, the way you draw these structures is given the prefix, you draw the number of carbons associated with the prefix. So in this case, it's meth. So that's going to be 1 carbon. And you fill in the rest with hydrogen. So this is CH4. So for B, ethane. Ethane. So that's 2 carbons. And you fill in the rest with hydrogens. The next one, C, is pentane. Pent, that's 5, so you draw the 5 carbons. 1, 2, 3, 4, 5. And you fill in the rest with hydrogen. So this is going to be CH3 dash, C2 dash, CH2 dash, CH2 dash, CH3. So that's pentane. D is cyclopentane, and this allows you to draw it in a line angle structure. So prop is 3. So here is the line angle structure of cyclopropane. Okay, let's name alkane structures that have substituent groups. So in this case, once again, it's an alkane, all single bonds, so it's going to end in ane. What is the longest chain? 1, 2, 3, 1, 2, 3, it's 3. So that's going to be prop. So this is a propane. But it has two substituent groups. And both groups are methyl. That's a methyl and that's a methyl. And they're both methyls are on carbon 2, 1, 2. So this is going to end up being 2, 2 dash dimethyl propane, 2,2-dimethyl propane. Okay, let's do B. B. Pick the longest chain, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5. So the longest chain is 5. Again, it's going to end in ane. Five is pent. Pent. There are two methyl groups. We could name them in this direction or that direction. So in this direction, it would be 1, 2, 3 methyl, 4 methyl, or we could name it in this direction, in which it would be 2 methyl, 3 methyl. We choose the direction that produces the lowest numbers. So that's going to be 2 methyl, 3 methyl. So I'm going to move this over a little bit. Give me more room. So this is going to be 2, 3 dash dimethyl pentane. 2, 3 dimethyl pentane. Okay, let's name this one. C. Longest chain. 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 6, 7. So it's 7. Again, it's going to be a endenane. 7, so that's heptane. So this is a heptane. Heptane. It's got 3 groups. This group and this big group and that big group. The numbering direction, this is on 2, 1, 2, 3, 4. In that direction, it's 1, 2, 3, 4. So it doesn't matter which direction we go, it'll give the same name. So in this case, if there are multiple groups, we may want to just make a little table as to what those substituent groups are. So here we have a 2-methyl. One, 2, 3, 4, 5, 6. We have a 6-methyl. And then we have this big group. This turns out to be a tertiary or tert butyl methyl. Tertiary butyl group. So, and it's on carbon 1, 2, 3, 4. So this is going to be 4 tert for tertiary butyl. 4 tertiary butyl. Now, how do we arrange them? Well, it turns out that we do it alphabetically. B comes before M, so this comes first. Why don't we use the tert? Tert really doesn't describe the molecule, just its composition. So but is really the name of this substituent group. This gives the orientation. So this goes first. 4 tert butyl We got 2 methyls, so that's going to be 2, 6 dimethyl. So this is 4-tert-butyl-2,6-dimethylheptane. Okay, let's go with D. Longest chain, 1, 2, 3, 4. So this is going to be ending in ane. 4 is bute. So this is a butane. It's cyclized, so it's cyclobutene. It's got a substituent group that's hanging off. So it's one substituent group. It could be on any corner. We need not designate a number. And that group is a methyl. Methyl. So this is methyl cyclobutane. And finally, let's do E. Longest group. Again, it's an alkane, so it's going to end in ane. 6 carbons in the longest chain, so that's hex. They're cyclized, so cyclohexane. There are 2 substituent groups, a bromo and a chloro. B comes before C, so this gets a 1, so it's going to be 1 bromo, 1, 2, 3, 3 chloro, cyclohexane. So for this question, we're given the name of the structure, and we're asked to draw it in a condensed structural formula. So again, when you draw things, I tend to first put in the carbons. So this is an ane, so they're going to be all single bonds. It's pent, so that's going to be 5 carbons. 1, 2, 3, 4, 5. There's 2 methyl groups, so let's put in those methyl groups as carbon. 1, 2, 3. They're both off carbon 3. 1, 2, 3. It doesn't matter which direction. So this is going to be a carbon up here. This is going to be a carbon down there. So this is CH3, since it's a terminal carbon. This is CH2. This is no hydrogen, 4 bonds to carbon, 1, 2, 3, 4 bonds. This is a CH2. This is a CH3. These are also terminal carbons, so they're CH3, CH3. Okay, so that's how you do A. Let's do B. B is 2,3,5-trimethylhexane. It's an ane, so all single bonds. It's a hex, so that's 6 carbons. 1, 2, 3, 4, 5, 6. Okay. There are 3 methyl groups. Let's just call this carbon number 1. So carbon, there's 2. That gets a methyl group. 3, 1, 2, 3. This gets a methyl group. Doesn't matter which side you draw it on. 5, 1, 2, 3, 4, 5. This gets a methyl group. So that is, you just fill in the hydrogens. 3. This is H. That's just 1 hydrogen. 4 bonds to carbon, 1, 2, 3, 4. This is CH. Again, just one hydrogen. 1, 2, 3, hydrogen is 4. This is CH2. This is just an H. H. 1, 2, 3, 4. Terminal carbon, CH3. Terminal carbon, CH3. 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 So this is the structure for 2,3,5-trimethylhexane. C. Let's do C. C is an octane. So that's 8. Let's put in these 8. 1, 2, 3, 4, 5, 6, 7, 8. It's going to have 8 carbons. 3 is an ethyl. 1, 2, 3. 3 is an ethyl. So I'm just going to put in the ethyl. CH2, CH3. And 5 is going to be an isopropyl. 1, 2, 3, 4, 5. So that's an isopropyl, so that's going to be a CH, CH3, CH3, that's isopropyl, and just fill in the hydrogens. A CH3 dash, CH2 dash, 1, 2, 3, hydrogen, dash, CH2, dash, 1, 2, 3, hydrogen, CH2, CH2, CH3. Okay, so that is 3-ethyl-5-isopropyl octane. All right, let's do D. D, I'll put D up here. Okay, so the name is 1-bromo-2-chloroethane. It's an alkane, all single bonds. Ethane, eth is 2 carbons. I put in the 2 carbons. Carbon number 1 gets a bromo, Br. Carbon number 2 gets a chloro, Cl. Okay, fill in the hydrogens. So this is CH2 dash, remember 4 bonds to carbon, 1, 2, 3, 4, and this is also a CH2, 4 bonds to carbon, 1, 2, 3, 4. So this is 1-bromo-2-chloroethane. I mean, why isn't it 1-chloro-2-bromoethane? Bromo alphabetically comes first, so it gets the 1. Okay, this question asks for the line angle structural formula for each of the following. So line angle is pretty simple. Once again, it's an alkane, so that's all single bonds. The parent, the prefix is hep, so this is 7. So this is 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? And on carbon 3 is a methyl. 1, 2, 3. Or it could be 1, 2, 3. So it's a methyl. There you go. So that's 3-methyl heptane. Let's do B. Alkane, cyclopentane. So that's 5. So we have a 5-membered ring. 1, 2, 3, 4, 5. So that's cyclopentane. 1 gets the chloro. So this could go anyway, really, but as long as you set that as carbon 1, then 3 gets the ethyl. 1, 2, 3. So ethyl is going to be 1 carbon, 2 carbon. So this is 1 chloro, 3 ethyl cyclopentane. Okay, let's do C. C is bromocyclobutane. So ane, all single bonds. Bute, it's 4 cyclo. So this is going to be a box. So this is cyclobutane. And bromo, notice it doesn't say 1 because it doesn't have to relate to anything else. So pick any corner and put in a bromo. Okay, this is 1,2-dichloroethane. Hexane. So this is D. Hexane is 6, so that's 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 gets a chloro. Let's start here. 1, 2, this gets a chloro, and 3 is a chloro. So that's 2,3-dichlorohexane.